Hello everyone and welcome back. My name is Mr. Cobalt, and in this video I'm going to go over a particular problem that can be a little tricky. In this problem we're going to determine what the relative masses are of elements X and Y that are found in two different compounds that are produced in two different reactions based on different amounts of X and Y in the reaction. So let's go ahead and get into this. So here's the problem. Let's go through the problem. So you're given elements in X and Y are gases in their natural states. These elements are going to react to form two different gaseous compounds as shown below. And this is going to be under constant volume, constant temperature. So that way we can treat the volumes in the same way that we treat moles. So when we have volumes under the same temperature, same pressure, same volume, um, uh, that's going to allow the volumes. Sorry, not the same volume. That's going to allow the volumes to be proportional to the moles or the amount of the gas. So we're going to assume here that all gas is under the same pressure and temperature. So again, under those conditions of constant pressure, constant temperature, then volume and moles are going to be proportional to each other. And therefore, when we're talking about moles of a gas, we can think, volumes of gas, we can think of that in the same way we would do moles. So you'll see that work out in a moment. So here we're given that 1 mole of gas X reacts with two volumes. Sorry, I keep saying moles. So 1 volume of gas X plus 2 volumes of gas Y is going to give us 2 volumes of compound number 1. But if we have double the volume, or 2 volumes of gas X and 1 volume of gas Y, then we're going to get 2 volumes of a different compound, compound number 2. Okay, so we're given that, and then we are given the mass percent of these two compounds. So the mass percent of the two elements in each compound is going to be different. So compound number 1, the percent by mass of X is 30.43% X, and we have 69.57% Y. But in compound number 2, it's kind of flipped. So we have 63.64% X by mass versus 36.36% by mass of Y. So then the question is, assuming that the simplest possible formulas for the reactants product, so we're assuming simplest possible formulas, determine the relative atomic masses of elements X and Y. What does that mean, relative atomic masses? Basically, it's a ratio of the masses. So for every atom or of X, how does that mass compare to an atom of Y? What's the ratio of the mass of X to the mass of Y? So that's what we need to find. We need to find the ratio of mass of X to mass of a single atom Y. Okay, so let's go ahead and start to figure this out. So since we're given the volumes of the gases, and we're told that it's under constant temperature and pressure, we can treat volumes like moles. So let's write out our balanced equation using subscripts for the elements, because we don't know if these X and Y, we don't know if they're monoatomic elements, diatomic elements, triatomic elements. We don't know, right? That would be an assumption we can't make. So when we write out our formula, or we're gonna put subscripts for the possible subscripts. We're going to put letters. Sorry, we're going to put letters for the possible subscripts, and then we're going to figure out what those subscripts are going to be. So what do I mean? So here we have 1 volume of gas X. So we have that. We'll treat that as 1. So we'll do the coefficients. So the 1s and the 2s, those will be coefficients. So we have 1x and we'll say that's A, plus 2 volumes of y, so we'll say that plus 2y, and then this will be B. We'll do a subscript B. Let me make sure I'm doing that. Okay. And so that's going to produce 2 volumes of compound 1. So 2 for the 2 volumes. And then we don't know what compound 1 is, so we're going to have to put these x and y together with, again, letters as subscripts. So x, and so we'll do C, and then y subscript D. So this is our compound. Again, we don't know what the subscripts are, so we're just using letters. So A, B, C, and D here. And then we do the same thing for the second equation. So here we have 2 volumes of x, so we're going to have 2. And since we're dealing with the same substances, then the subscript should stay the same. So here we have x again. It's going to have subscript A because it's the same. But the only difference is the volumes or the amounts we're using are going to be different. So here is going to be 1 volume or 1 mole of y. And again, y has subscript B. We don't know what the formula for y is. So we're going to have B there. And then that's going to produce compound 2. So again, it's going to be 2 volumes of compound 2. So 2. But since this compound is different, we can't assume that the subscripts are going to be the same. So we need different letters for these subscripts. So it'll be X, and then since we stopped at D, this will be E, and then Y would be F. So A, B, C, D, E, and F. Let me double check to make sure I got that right. Yep. Okay. So I just want to make sure this is fitting my notes that I have. So now I have my equations with the unknown subscripts. And so now here we need to figure out what are subscripts. We need to solve for the subscripts. And the key here is that we want to assume the simplest possible formulas. So simplest possible formulas, we want the simplest whole number ratios. So what we do is we're going to have to make sure that both sides are equal in terms of the number of x's and y's, because remember, conservation of mass, the law of conservation of matter and mass, means that the number of x's and y's on both sides of the equation are the same. This is the balancing of the equation. So assuming that the equation is balanced, then the total number of x on one side should equal the total number of y. Well, we have a number of x, excuse me. So we have 1 times a gives us a number of x's. So 1a. So we got that's the total number of x's on this side. That's going to be equal to the total number of x's on this side, which is c. We have 2 times c gives us 2c, a number of x's. So that's got to be equal to the 1a. So this is going to be 2c on the one side. Okay, so because of the law of conservation of mass, balancing equations, number of x's on this side should equal the number of x's on this side. Here I have 1 times a. Here I have 2 times c. So 1a should be equal to 2c. Okay, so with me so far? And then, so then on this side here, we have the y's. And so the y's are the same. So we should have, on this side, we have total of 2 times b for the y's. That's the number of y's. So we'll have 2b. That should be equal to the same number of y's on this side. So here I have 2 times d for the y. So that's going to be 2d. D. So this is X for the X's, and this is for the Y's. Okay, so with me so far? So then we do the same thing for this equation here. So for X again, it's going to be 2A. So 2 times A gives us the total number of X's on this side. So 2A. So we'll do X. So 2A amount of X. So we're multiplying the coefficient times the subscript to get the total. And we do the same thing on this side for this X. So 2 times E is going to be the same for these X's here. So that's going to be equal to 2E. And then for the Y, same thing. So 1 times B for the Y. So 2B, or I'm sorry, 1B. Where's my eraser? So 1 times B. So 1B on this side. That's going to be equal to 2 times F on this side. So 2F on this side. So now you see that here for the X's, for both equations, we have 1A is equal to 2C. And then here we have 2B is equal to 2E. And then here we have 2B is equal to 2D, and 1B is equal to 2F. And so let me double check this for a moment. Okay, so we got that. But there is a mistake. X, so this should be A. So I got to change that to A. Otherwise, this is not going to work. So don't make that mistake. So double check. So 2A is equal to 2 times E. There we go. Okay, so now if we look at the X's, look, we have 1A is equal to 2C, 2A equal to 2E. If you drop out the 2, right? So that means if we divide both sides by 2, then basically you have A is equal to E. And so if you put these two together, so 1A is equal to 2C, but 1A is equal to E. So if we put that together, then 1A is equal to 2C, which is equal to E. Okay. So remember, these are the different these are the different subscripts for X. So we want the simplest possible formulas. Well, the simplest possible formulas is going to be with one of the subscripts has to be a 1, right? For the simplest possible subscripts. And we want to put this so that the subscripts are whole numbers, right? So one of these should be a 1. And if I do a 1 here, if I make A1 or if I make E1, right, then what's going to happen is when I solve for C, I'm going to get a fraction, 1/2. So I can't have a fractional subscript. So to make it the simplest, I'm going to make C equal to 1. So if C equals 1, we'll just put it over here. I'm going to say C is equal to 1. Well, if C is equal to 1, 1 times 2 is 2. So that means E is equal to 2 times C. Well, if C is 1, 2 times 1 is 2. So E is going to be equal to 2. But then 1A is equal to 2C as well. If E is equal to 2, then 1A is going to be equal to 2 as well. So then I write down A is equal to 1, and since A is equal to E, then 2. That should be a 2. If A is equal to 2, then E is equal to 2. So let me just say that again. So I want the simplest possible formulas. So that means I need a 1 to something ratio. So one of these subscripts, I can make a 1, and therefore I can figure out what the other subscripts are going to be. And I don't want fractions. If I make A or E1, a subscript 1, then that's going to, when I solve for C, I'm going to end up with a fraction of 1/2. I don't want a fraction of 1/2. So, but if I make C equal to 1, then when I solve for E and A, they end up being a subscript 2. They give a whole number of 2. So now I figured out what C, A, and E are, and I do the same thing with the Y's. So here I have 2B is equal to 2D. Well, that's the same as B is equal to D, right? Same thing here. If I divide both sides by 2, I get B is equal to D, right? So B is equal to D. And then here I have B is equal to 2F. So B is equal to D, which is also equal to 2F. And so I do the same thing here. One of these I'm going to make equal to 1. I'm not going to do that for D or B because if I solve for F, I'm going to get 1/2. I don't want a fraction for a subscript. So I'm going to make F equal to 1. So F is equal to 1. And so when F is equal to 1, that means D is equal to 2 times F, which is going to be 2 times 1, and that's 2. So D is equal to 2, and then B is equal to 2. So D is equal to 2, B is equal to 2. So now I have the subscripts of my formulas. So now all I need to do is replace the letters with numbers. So let's go ahead and do that. So here I'm going to have A. We said A is equal to 2, so 2 and 2. B is equal to 2. So we're going to have subscripts 2 for the Y's. So that's 2 and 2. So it looks like we have diatomic elements. And then C and D. C is 1 and D is 2. So C is 1 and D is 2. So we usually don't write the 1 subscripts because we have the X there that represents 1. And then E is 2 and F is 1. So here, 2, X is 2, we have a subscript, and then the Y is 1. So look here, we have X and Y, we have double the amount of Y compared to X for compound number 1, which if we look at the percentages, X versus Y, look, you got double amount of Y. So it makes sense. Here it's flipped, so you have double the X and Y. So it matches what we have here. Great. Okay, so we're not done yet though. So now at this point, remember, our goal is to determine the relative atomic masses of elements X and Y. We need a ratio of mass of X to Y. That's what we need to find. So let's go ahead and do that. Okay, so if we do compound number 1, so now that I have the subscripts, I can erase all of this to give some room here. Hopefully you have that written down. Okay, so we want to determine the relative atomic masses of X and Y in the compounds. So this is compound number 1. Look at the relative masses of X and Y. So here we're given the percent mass of X and Y in the compound. So we can use this percent as a ratio and then compare that with this here. So what do I mean? So I have X and Y. So let's get X over Y. So the percent mass of the compound is going to be the total X over the total Y. So that's going to be, let's see here. So X over y. Now here I have two y's, so this is going to be 2 y's. So we're only looking at the formula here, right? So the percent by mass, this is the percent by mass of the elements in the compound. So here you have x 30.43%, then you have y. So the total mass, the percent by mass of the whole compound with y is 69.57%. So this is the mass of x over 2y because I have 2 y's in my compound. So this accounts, these 2 y's account for 69.57%. So I can do this as a ratio as well. So the percent of y I can put on the bottom, percent x I can put on top. Because if I assume, let's assume 100 grams of compound 1. So out of 100 grams of compound 1, 69.57 grams is going to be y. 30.43 grams is going to be x. So we can just assume 100 grams. So x is on top, 30.43. And then y is going to be on the bottom, that's the 69. So 69.57. Okay, so with me so far. Hope you are with me so far. So in this case now, I have the percent, I have the ratio of x to y in the compound, right? 2 y's in my compound, 1 x in my compound, and here's the percent by mass of the x and y in the compound. Now, they're not asking me for the percent mass, they're asking me for the relative atomic masses. Okay, so the relative atomic mass is going to be the mass of 1x compared to the mass of 1y, right? Here I have x to 2y. So I need to change that and I need to solve for x over y. Well, how do I do that? I multiply by 2 on both sides. So if I multiply by 2 here, I then multiply by 2 here. The 2's cancel out, and I get my ratio of x over y. So the ratio of x over y is going to be the relative atomic masses, my fractional my relationship there. And then all I do is I solve for this. When I do, I get 0.8748, 0.8748. So this tells me that for every 0.8748 grams of x, I get 1 gram of y, right? So it's a ratio of this over 1. Okay, so this is the relative masses of elements x to y, right? So that's one way I could do it. Now, notice that I got this value using compound number 1. Well, I can do the same thing for compound number 2. If we do the same thing for compound number 2, it's the exact same thing. So I have the mass percents of x to y in the compound. Well, in compound number 2, it's going to be 2x's over 1y because this is my formula, and the percent by mass is based on what's in the formula. So then if I do this again, do I have room over here? Yeah, I have room over here. I can do, in the compound number 2, it's going to be 2x over 1y, and that's going to be equal to these percentages in the same ratio. So I have 63.46, right? And I have 36.36 for the y. 36.36. And again, the mass percent here is if I was assuming 100 grams of my compound, 36.36 grams of that compound would be y, and 63.64 grams would be x. So I have 2x over y. If I have 100 grams, then 63, this 2x portion would be equal to 63.46, and the y portion would be equal to 36.36 grams. So now I have it set up, but again, I want x over y. I don't want 2x over y. I want just x over y. I want the relative mass of 1x to 1y. In this case, I would have to divide by 2 to cancel out. I get my x over y, and I get the ratio of 0.8751. 0.8751. And you can see here that they're very, very close together with each other. So I don't exactly know why this is a little bit different, but they're pretty much the same. And that's how you find out what the relative masses of x and y are to each other in this problem. Excuse me. I hope you enjoyed this video. I hope this was helpful. If you enjoyed this video, if this was helpful in any way, then please like the video, share the video, hit that like button. Also, make sure that you subscribe to my channel, hit that notification bell. When you do, make sure you click all. And then make sure that you put a comment down below in the comment section. Let me know what you think. Ask me questions. I would love to hear from you. If you have a topic you want me to cover, if you have a particular problem or question you need help with, put that down below. I would love to help you with that. Thanks for joining me, and have a great day.